Joining me today on Startup Report is Darren LaCroix, who's the founder of Code-X. Welcome, sir.
Welcome. Thank you.
And welcome to St. Pete.
Appreciate it. We're happy to be here.
About 10 months in?
Yep, about 10 months. So
we're glad to have you. You told me you've been working with JP at the EDC and taking over a floor in the station house, and got the right people in the right places, so you're doing all right.
That's right. Yeah, no, we're excited to be here. We really feel the community is a way to go for what Code-X is looking to do, and we're excited. Our roots are growing here in St. Pete.
That's great. So let's dig into Code-X so we can get our bearings, and then we'll go from there.
All right.
Five dimensions, cybersecurity, a lot of cool stuff tied to a lot of your clients historically, and some other companies you've been in have been in the defense space. Now you're kind of branching out into the big wide world of standard businesses and whatnot. So let's hear. I'd love to hear an overview of what Code-X hopes to accomplish.
Absolutely. Code-X is a rather unique technology, and I'm sure most people say that about what they're working on. But we truly took a step back about 3 years ago and decided to design something that could work better in an environment that's constantly growing. And in the world of technology, there is this strange parallel issue when it comes to the growth of everything from processing through to memory, and the advancements in that, which are normally a major benefit in the world of technology for the consumer and for the warfighter and for others. But in the world of security, it's a bit of a difficulty, because as these items grow, your adversaries have the ability to create a malicious environment and malicious attacks easier than they used to. And so if you come look back as far as the 90s, what used to take a nation state capability to form an attack on everything from a pipeline through to a large scale database in healthcare is now two guys in a garage and $5,000. You know, when you can set up that kind of power toward somebody's information, you need to start thinking differently. And so to continue the parallel process of technology to the security need of this world needed to be broken. And that's what Code-X did. So with the 5 dimensions you talked about, Code-X has created the first successful lattice-based multidimensional approach to security. And one of the major reasons we did that was the thought process of break this parallel. This parallel is built on the idea of increased security as the threat grows. Well, we can't do that anymore. We know it's a finite and end game that doesn't work, and we're seeing that in the news on a regular basis. So we decided, how do we reduce vulnerability? Don't increase security. That'll come out if we do things right, but reduce vulnerability. And so our lattice-based multidimensional approach creates 5 dimensions of capability inside of a system that are all working simultaneously and in parallel. And when that happens, you end up reducing many of the vulnerabilities that are inside of your system, from malicious attacks, hacker tool sets, so on and so forth. The dimensions themselves are number 1, fractionalization. Fractionalization is how we structure the information from the moment of its inceptions and or the implementation of the Code-X engine. Dimension number 2 is the ability to multipath. Multipath is not a new technology. But the way we do it, utilizing a spread spectrum technique and the fractionalization with our watermark, is actually quite unique. Dimension number 3 is the watermark that you just heard me talk about. Our ability to tag information in a way without ever transmitting or creating a key across the network. We do this through the utilization of constants inside of the system. Constants inside of the system, then coupled with time, allows us to create an irreplicable tag to a piece of information at a point in the IT universe. Dimension number 4 is then authentication. Authentication, very specifically, might be one of the most important parts in everything that we've been talking about. Do I know who I'm talking to? Is this a trusted party that I am talking to? It's that zero trust type of world. And so when we have authentication via our dimensions and the watermark itself, that enables us to do what we call intelligent machine authentication. It means machine A, machine B actually know exactly how they talk to each other and how they used to talk to each other milliseconds ago in the computer world. And if that changes in any form or fashion, we know something took place. And was that authenticated? Was it a bit error rate, which are extremely unlikely in today's networks? It gives us a live ability to fix, move forward, and understand what's going on inside of our system. Eliminate a major set of tool sets, ghosting machines, so on and so forth. And then there's dimension number 5. Dimension number 5 is called measurement of change. It's our ability to take all of that information and understand if something is different inside the environment. Are we being attacked? If you touch our system in a malicious way without being authenticated, without understanding how all the other processes are going on at the same time and where they're coming from, we know that you have touched the system. Therefore, within milliseconds, we have the ability to react to it. Now, those are not prioritized dimensions, 1 through 5. It's just the way that we list them out. They all happen simultaneously and in parallel. And that is the way that we heavily reduce the vulnerabilities inside of a system instead of, quote unquote, increasing the security. And probably one of the most important things from the overview that you just asked me about was we don't use algorithms. We take the math out of the equation. We take the processes out of the equation that allow increased processing power, increased memory, reduced cost of infrastructure. We take all of those things out of hackers and malicious parties' systems and capabilities. And we utilize something that no longer is a repeatable process of guesses. When you eliminate that from today's security world, you end up with a major advantage going on inside of the system. And that's Code-X from a high level.
That's great. Several things to dig into, obviously, and I guess I want to start with the first couple items with regard to the data, and with the obscuring the beginning points and the end points of data, and then can you explain how that ties into the pathways, the multiple
Absolutely.
pathways? Yeah,
certainly. So to your question of the obscuring the data and the fractionalization, the dimension number 1, what's very important about fractionalizing the data is when you take all of the information inside of a system and you make it equal and identical blocks, no matter what size that is. Let's just use 4 kilobyte as a standard. We have tested all the way down to 6 bits with interleaving, for eliminating any actually true data inside of a system. When you do that, you eliminate the beginning and end points of that original algorithm of what information looks like. So there is no puzzles. When you go to do a puzzle, the pieces have very interesting sides. They give you clues as to what that puzzle looks like with a picture on it. Well, if you eliminate the picture and you eliminate the sides, there's no beginning. And I like to relate this a lot to kind of Legos. If you ask a 5-year-old to build Millennium Falcon out of Legos, and then you give them a bucket of blue 2-prong Legos, they're going to sit there and look at you and be like, what's next? Versus giving them a Lego kit, which is how databases normally look in many scenarios, even encrypted or not. They actually have an understanding of a starting point and somewhere to pull at.
So then is it fair to think of that then as a disassembling and reassembling exercise that's controlled by, that's driven by the system?
In a way, it's better to say a restructuring. So disassembly would mean that we actually destroy the information. We change the way it travels and gets stored. We don't have to worry about the application data. We don't have to worry about database tagging. We don't have to worry about provisioning and issues across networks. We work underneath all of that. So we're taking what your system's doing, and the Code-X itself is starting to manage it differently, which means the outside world no longer gets to view it the way that you would get to view it. So as a major separation, that's a part of that zero trust conversation that we've had, where I don't trust anybody else, but I view the data the way I want to. Nobody else is ever going to see it that way.
Got it. And then as we move in sort of the third with the watermark, that starts to mimic blockchain, right? And to the extent that you're verifying previous batches or blocks of data with current blocks of data, but you're doing it in a unique way that's more efficient than the traditional blockchain method. Is that?
That's correct. It's funny. My colleagues would twitch a bit when somebody says the word blockchain, because there's some major issues in the world of utilizing blockchain. Blockchain is a great technology for what it was trying to accomplish, but it's extremely inefficient. So when we designed Code-X, the watermark gives us the ability of all that validation and proof of stake, proof of work capability without the massive implementation management and interoperability issues that come with the distributed ledger technology, which for those watching, distributed ledger technology, blockchain, same thing. Okay, that's the general idea. You have thousands of databases all sharing information, and you would have to hack them all to change anything, and then they would all have to agree. It is a difficult thing from that standpoint. What we do is we allow the machines through the watermark to take care of all that without recreating the data. And so it becomes extremely efficient with the same benefits.
Got it. So there's no need to involve the world in it, essentially.
That's right.
And so, given that, how do you think a technology like that overlays with use cases where people think this may be a blockchain thing in the future, but more realistically, corporations and entities, governments, or whatever, will lean more towards a technology like you're using because they don't require. They're happy to get that same level of immutability and security. But without having to go out to the world and share have the databases all over the place.
Well, I think you hit it there at the end. So to the question of how this overlays replacing blockchain, for lack of a better way to ask the question, if I'm listening to the way that you're talking about it, is or overlaying with it, is we take away the inefficiencies while still giving the same value. But instead of being an R&D project every time you have to implement something or manage a user, we actually have a return on investment. What we do to the storage and other environments inside your system gains significant efficiencies while reducing the overall cost of a system itself.
Right. And the use case for that, just to be clear, is that the decentralized nature of it works when you have players all over the place that need to interact together. But in most of these use cases, you don't have that. You have one organization that just wants internal security.
In a way, yes. I would disagree with that slightly because the decentralization that came out of blockchain is, in my opinion, somewhat irrelevant to IT systems. So when you're dealing with a global network like we all live on now, it is nothing but decentralized information. It's all over the cloud. We hear cloud all the time. Cloud is decentralizing your data. You've already spread it across servers that are all across the world, whether you ask them to be in one place or not. It's the same on a larger, smaller, micro, macro type footprint. So when you include, distributed ledger inside of something, all you're doing is trying to use far more resources to do the same job that Code-X would do. So, to answer your question directly, no, it's not just for a private environment. We actually are far more efficient in private, public, and hybrid environments. Whereas if you look at the distributed ledger type technologies, you're just taking what you wanted to be very private and allowing a whole bunch of peers that you didn't want in your information.
Got it. And so then, just again, I love digging into this. The immutability piece is there either way.
Yep.
But if people need to transact, people who have never met want to come together. The traditional example is a DAO or something like that now, and do business and have it be trustless, decentralized, permanent, immutable. You can accomplish that with the technology you're using.
Can we accomplish that? Absolutely. So in a scenario like that where you have a transactional base taking place that's coming from outside the system, you have the ability to create an authenticated portal or an authenticated user app. So one thing that's very unique and interesting about Code-X is we're extremely lightweight. So in the world of information, when you send a picture to a friend on your phone, that's anywhere from 800 kilobits to 4 megabyte, depending on how nice of a phone you have going on. Our entire engine is 1.4 megabyte. It's smaller than the average picture across the internet. So if you have people that you would like to do transactions with, you easily can push down in a script format the engine to that system and allow them to authenticate, get on the system, and communicate with your system without any major reprovisioning or other issues around that. What is actually, even more beneficial to that scenario when we start talking about eliminating vulnerabilities, normally when you do that, it's like punching a hole in a system. Code-X assumes that any and all malicious parties get our software. So that's why the system itself and the way it works is so important, not the software itself.
Got it. So, and you mentioned it's compact, despite its complexity, it's compact size. So, how does that then play into the use cases for it? Where do you see the first users of Code-X, and where does it go from there?
Well, that's an interesting question. And when you're a startup world, this show's all about Startup.mp, right? You try not to boil the ocean. So I'm always careful answering that question. So we'll do this one twofold, if that's okay with you. Where do we start is in the world of communications. And we're working heavy in the world of communications right now because we have the ability to eliminate what's known as initiating the kill chain. The fact that we don't initiate the kill chain means we allow small transactions to take place all over the net without anybody else know that they're going on, like communications. Second phase to that is as we take step by step and people look at us for everything from not just their communications platform, but through to, okay, my entire environment, storage, so on and so forth. This should be happening because I have zero trust issues all over the world now. And this is kind of a new term that really people are finally getting used to is zero trust. It means I don't believe anything that I'm communicating with inside of my system is something that I can trust. And we give you that benefit with this implementation. So when you start looking at the progressive levels of, okay, you understand we work in communication, without changing the technology, we now give you the trust of your own storage. Without changing the technology, we give you the trust of all the endpoints on your devices. And this is all a matter of you getting used to us because we've already implemented that for your communications to happen. So at the end of the day, my happy startup hat goes on is the fact that we will be in every piece of IT systems globally, including phones.
Including phones. Can you help me understand how the intra-organizational expansion happens? So is it, how are you fencing the data into the instances of your system?
So that's where the authentication piece comes from. Our system is very good without getting too far down into the proprietary nature of this. Our system is very good at restructuring that data and utilizing what's available in your existing systems to manage that data. If for some reason you weren't going to implement Code-X on the entire system, you can have a cordoned off capability with the Code-X engines managing your information and your communications for those specific users that are then interleaved and working with your existing storage servers. They're just different blocks, and those blocks then fall under the authentication. So expanding that is a matter of that authentication piece that I talked about. Do we want to bring this user into this environment? Do we want to bring the entire user into this environment? That goes back to your standard Active Directory capabilities out of Windows and other things that you're using right now. We work with all of that.
Got it. So then if you have, say you go into an org and they say, yeah, we want you in accounting and we want you in internal comms, and some elements of those, touch a database or something that's centralized. And then they say, yeah, this worked well in these two individual use cases. Let's bind it all together, include that database, and maybe go over and include logistics or something. Then is that then one? How do the blocks interact with each other as they were logically separated before? How do they all come together?
Well, so they're not logically separated. They are separated based on how they're authenticated. So the information is still all hanging out in the same places. It's just whether or not you're going to have access to them. So this is where there's no reprovisioning from that standpoint. Everybody already has access to these drives, but there's going to be certain people who can authenticate to certain information on these drives. And when you separate, because we actually go a step beyond most people in the world of virtualization, and you hear about SD-WANs and virtual storage and so on and so forth. We actually virtualize the network and the storage at the same time. So it gives us the ability to manage that information presenting to the application, which allows us to be very granular in how those blocks of data are managed. So when you have that, for us, it's as simple as adding another engine to the end user and or storage server that you want to include, not include to that system. So again, we go right back to 1.4 megabyte download, initial authentication, and you're up and running.
Got it. And just make sure. So if you have, obviously keeping up the, so if you have the two departments and you want to merge them, then it's simply authenticating the blocks that you have lying under the data that are that layer, allowing them then permission-wise to communicate with each other.
Right. Yeah. Just like old school Active Directory I mentioned, or if we want to keep it really simple for all the people who aren't on the tech world that may end up listening to this, it's like a group hug. You got to open the arms to let them in, otherwise you don't get involved. So that's really what it boils down to, is you get to have the permissions, and are we going to give them a new engine and the ability to authenticate to this information, or we're not? Or are we just giving them the ability to communicate with us but not see data? You will have that granularity by the access management systems that you already have in place. The only addition is pushing out the engine for the first time that you want to add somebody to the system. Same with removal. You can kick everybody out of it and just as easily.
So when you have a permission-based system, somebody has the authority to make permissions. Then so how does the system bubble up to the people who can actually determine permissions?
So that all comes down to the client choice. We can either manage that for you with our partners, or we can, hand the keys to you, so to speak, and allow your existing IT group and IT managers to have that capability. So that's up to you, and that's where if we tie it to, again, just the simplest and probably the most prolific out there, a Microsoft Windows Active Directory environment, then they will just continue managing users in the way they want based on the group levels that they are in.
Very cool. That's great. It sounds like a fun project.
It's been a blast. This is my life's work. This is Bob Twitchell's and Danielle's and Randy's, kind of life work all coming together. And a lot of people I could sit here and name inside of our organization that have kind of been around the block in changing the way information is looked at. And this one, we all just kind of sat down and we're like, we need something new, and the world needs something better. So here we are.
In St. Pete.
St. Pete.
Love it.
We're excited about that.
Well, Darren LaCroix, it's been great chatting with you. I appreciate you stopping by the studio, and we'll look forward to following your progress and supporting you in whatever way we can.
Thank you, sir. I appreciate you having me here today, and look forward to chatting again.